Assalamu alaikum, brothers and sisters, sisters and brothers. Let's slay some demons. We're going to talk about a few things today, but we're going to focus on my continued talk about mathematics. Now, we're told that we must have a thorough knowledge of self. Thorough knowledge of self. How can we have a thorough knowledge of self unless someone teaches that thorough knowledge of self? When it says thorough, that means comprehensive all, thorough, complete. Is there anyone out there giving you a thorough knowledge of self? Who is going to provide this for you? They'd have to have it themselves in order to give it to you. If they don't have it, then how can they give it? And if you are the God, then a thorough knowledge of self would mean just that. You would have to have a thorough knowledge of the creation. If this is your creation, that's part of the thorough knowledge of self. So whoever pretends to be giving you a thorough knowledge, they must have a thorough knowledge of the creation itself. And we're told that Islam is mathematics. Islam should have a thorough knowledge of mathematics. It's very simple, brothers and sisters. We're at the end times now. It was complicated up to now, but it was designed that way because we was under the control of a confused people, unrighteous people. As the Quran says, the more they study the creation, the more confused they become because they're not the creators. They're not the creators. See? So they cannot understand the creation. So we're going to go and give you more, and so you can check for yourself. Are you getting a thorough knowledge of self or not? Do you have a thorough knowledge of self? Do you know who you are? Your creation? Who your enemies are? What time it is? If you don't know those things, you do not have a thorough knowledge of self. Has anyone given those things to you? These questions must be answered. Now, those who are the inheritors of the future will understand these things. Those who are time anchors, that means they're guardians of the past, well, they will be left behind in the past. That's what the Quran talks about, believers and disbelievers. The disbelievers are always left back in the past. Disbelievers in scriptees. Because scriptees, they don't believe in change. Moses the last one. Jesus the last one. See? Prophet Muhammad last one. Elijah last one. Even though all the facts and all of them point to someone beyond them. So that's the scriptees. Time anchors. We don't worry about them. Leave them in the past. So we're at war, brothers and sisters. See if I can get a little better. Okay, that's a little better. We're at war, brothers and sisters. And as Elijah Muhammad asked you, who will survive? He said, who will survive? I'll take a little step further. Who will win the war of Armageddon? We don't want to just win. We don't want to just survive. We want to win it. We're here to win it, not to survive it. See? I mean, in a war, right? The prisoner of war, they survive it, but they're still prisoners. No, we want to win it, and we're going to win it, and we are winning. Who will win the war of Armageddon? We got two visions. We got the biological creation that we brought into existence. That's the spatial mind. And we got the analytical vision. That's KV. That's Dr. Yaqub's vision. Like the Dr. Shabazz vision, that's to take the creation, the original creation, and make it better. See? And Dr. Yaqub's vision, take the creation and remake it into a mechanical creation that they can rule. They cannot totally rule the biological creation. They cannot. It's too weak. They don't understand it. But they understand computers, at least to some extent, and mechanical things. You see it, they make the mechanical world all around you. Don't you see it, brothers and sisters? They build a mechanical world, which ultimately ends in a mechanical body. See, a robot is a mechanical person, mechanical machine that imitates a person. It's not conscious. That's not what they're after. After cyborg, which means you have a biological brain, but you have a mechanical body that can live as long as you want to live because they just replace the parts. See, once they achieve that, they don't need the creativity, our creativity anymore. Once they have achieved that, see, that's what they're looking for. So who will win the war of Armageddon? Who will win? We're here to win. It's a zero-sum game. Either you win or you lose. There's no in-between on this. Either you win or you lose. There's no survival. Whoever survives, if you just survive, you're in trouble. Like I said, losers survive, right? In subjection, in oppression. That's the kind of survival you want. This is our vision, paradise. See? The promised land. See? That's not their vision. They cannot live in that vision. Because you see, look, when they found America, America was a virtual paradise for them, and look what they've corrupted it. Because they don't understand the creation. They cannot survive in the biological. Look all the plagues and things that's going on. All the diseases that we are afflicted with. Most of the diseases was not here in America before they came, like the so-called common cold and things like that. They brought those things with them. And they turned the virtual paradise here in America into a hell. They're destroying it every day. The climate and everything, because they don't understand it. And they don't have the power to keep it as is anyway. But you have to understand it. See? I mean, would you take and build a factory inside your home? You wouldn't be able to breathe, right? Smoke and everything. Well, they do that here on this planet. And you think that's, oh, that's great. No, it's not great because we do that manufacturing, but we do it off planet. When we take back over, there will be no manufacturing done on the planet, on this planet Earth, right? It'd be a total paradise from east to west to north to south, total paradise. There won't even be any poles. It'd be a paradise, the whole surface of the Earth, entire surface of the Earth. But we have paradises all over the universe. We have trillions of planets all over the universe that we spend 76 trillion years putting, building, making. They're all habitable and they're ready. We don't have to do anything to them. Well, we can go and improve them if you want to, but we don't have to do anything to them. They're habitable. And we will be on those planets. And it won't take us long to get there. They say, oh, the speed of light. That's their idea. They thought the world was flat. How do they know the speed of light is the fastest you can go? And they haven't even achieved the speed of light. So how do they know that's as fast as you can go? See, that's a energy consideration. That doesn't mean mechanical things can't go faster than that. That's their idea. We're not going to waste time with that. But we're going to talk about some things here later on, right? That might shed some light on that. Okay, well, let me back up for a minute because I wanted to talk about something else first. Now, Elijah came. The scriptures are very clear. So anyone confused nowadays because they want to be confused, or they're demons, well, it doesn't matter if they're confused or not, because they have no portion in hereafter. See, the scripture is very clear. You follow Exodus. They do everything they can to get you off. See, back when we was in the fields, we're still in the plantation now, brothers and sisters. I'm not going to do all the details. We're still in the plantation. See. But when we was on a plantation, see, our ancestors used to saying, you heard it, go down Moses, go down to Egypt land, tell Pharaoh, let our people go. They just sang that song. So where did they get that song from? They didn't get it from Massa. They did not get that song from Massa, because Massa would not allow them to sing a song that's going to say, right, that God is going to come and kill them for doing what they're doing to us. Does that make any sense to you? They let them sing that song? No. Because they knew that song before they came over here. Because most of them was Muslims anyway. And they still respected the Bible then. See, the Bible wasn't disrespected back then. The Bible has been disrespected so by Sunnis after we came over here and when Elijah Muhammad came along, and all of a sudden, oh, you can't trust the Bible anymore because the Quran tells them they must believe in the Bible. It says you must believe in all the prophets, it says a lot in the Bible and all the script. You have to believe in all that. It says because Muhammad is the seal of the prophets. I mean, he can't put the seal on everything that was before him to prove that it was from Allah. And you have to believe in it, certify it. That's what it means to seal. But they don't want you to do that because if you follow the Bible, oh, they got trouble. See, so all of a sudden the Bible is no good, even though Allah says he will perfect his life. His life is scripture. He says he's going to corrupt it, perfect it. So that means you have no excuse. See, so all this stuff about the Bible, that wasn't. See, because they tell you, hey, they protect the people of the book, right? What book? The Bible. They talk about the people of the book. All this nonsense about the Bible, all this stuff with Sunni and all that kind of stuff is new. And most of it is as a result of Elijah Muhammad's teaching. So that song, they knew what that Exodus meant. They knew the song. They knew what that meant. And the preachers wasn't there to tell them and teach them to sing that song. Nowhere in the world the preachers would have been sent to tell them to sing that song. They were sent to tell them stop singing that song. That Exodus didn't have nothing to do with you. That's past. See, you're cursed. See, you was cursed to be black, have nappy hair. See, you're a product of evolution. See, you're the missing link between the human and animal. They had to search for the missing link. It was a big thing when I was a child or before. The missing link. We were supposed to be the missing link between human, right, and animal. Between white folks and apes. That was supposed to be us. So we wasn't really human. It says that in the Constitution itself, only 3/5. All this stuff they're trying to cover up now. They didn't want you to sing that song because it was obvious that song, but that was about you. And all these preachers, they was told not. That's why they don't sing this song, and they don't sing songs anymore. You see what happened to Reverend Wright? He starts quoting the scripture. They shut him down. They can't have you thinking like that. They know what the scripture is, and they had these preachers set you down. Why all of a sudden they had preachers had to go to school to get what they call them, certified or what? I've got the name they use, right? So they had to go to school to get anointed or whatever they call it. Why? Did Jesus have to do that? Right? Go to theology school? Did Moses have to go there? You see? Because they go there to make sure you have their understanding of what the scriptures mean. That's why you have to go to those places to get certified, whatever name it is, right? Ordained. Be ordained as a minister. How are they going to ordain you as a minister? To ordain you as a minister, right? You get ordained. That means you have to say scriptures the way they explain it. You have to accept the way they're telling you. Like Exodus happened in the past, right? And millennia is in the future, and all this kind of stuff. So that's why you have to go to good schools, these seminaries and everything to get ordained. Get certified. Make sure you understand scriptures like they want you to understand it. They told us scriptures, don't be teaching that promised land stuff. And so preachers don't teach it. Even if they knew it, they don't teach it. That's why they didn't recognize Elijah. That's why the preachers recognized Elijah, but the people didn't. Because the preachers made sure they didn't. Like they made sure they don't understand Suleiman. They made sure they didn't. That was their job, to make sure you don't understand that you disconnect with all this stuff. Because Martin Luther King, right, they told him, do not talk about that promised land stuff anymore. He went and talked to Elijah Muhammad. Elijah Muhammad stiffened up his spine. What he did, he went and gave that speech, the promised land speech that killed him the next day. Next day he was dead. Because they don't want you to understand all that. But Elijah, even these people, Farrakhan, they're the same thing. They distort the scripture. It says right there clearly that the messenger of the covenant, that's a filler of the covenant, the messenger of the covenant would suddenly come to Elijah's temple. But is Elijah's last one? Well, who is the messenger of the covenant then? He's a messenger. It's right there in Malachi. So if you believe Malachi and you believe that Elijah Muhammad is the one they talk about Malachi, then what's the problem with the messenger of the covenant? The one that comes after him. The one that he was supposed to prepare the way for. He was supposed to prepare the way for him. He's supposed to build a bridge. And he did. He set up, he taught the Levites, because Elijah was a Levite, taught the Levites how to build a bridge. He showed them what to do. He set it up. And then he left them. And what did they do? Along comes Farrakhan. They don't build, they want, and they destroy everything. You understand? The knowledge of everything Elijah Muhammad gave them to build a bridge. And they start building mansions for Farrakhan. See? So that's what happened. Because he's supposed to build a bridge from Elijah to Suleiman, from Moses to Joshua. See that person in the middle there, Aaron? Bad news. They know it's bad news. But he can't come and tell you that follow Exodus, because if he follow Exodus, that means he's toast. Because Exodus, Aaron was a spokesman of Elijah. He was a spokesman for Moses. Who was a spokesman for Elijah? Farrakhan. Wallace was never a spokesman. And he betrayed Elijah, right? Betrayed Moses. Whose Moses was gone. Moses was gone about 42 years. Whole 42 years, all he did was deceive the people, confuse them, turn their hearts back towards Egypt, towards the plantation. We ain't going anywhere. We ain't leaving this plantation. That was Farrakhan's church. We're not leaving this plantation. We're in plantation America. This whole thing, you're still in the plantation, bro, so you just don't understand it. We ain't going nowhere. When Elijah Muhammad stated, and I have the clip, right? He says, we'd be a fool to stay here in the land of our imprisonment. So why does Farrakhan tell you we ain't going nowhere? He lacks it here on the plantation. See, and you read the book of Mark, right, where it talks about the demon-possessed man, and Legion Louis Eugene Grounds are in our backwards, right? The first thing he said, please don't make me lead a country. Want to stay here. Want to stay with his devil daddies, his swine daddies. So understand that. Okay, so we're going to move on into the presentation. But when it says thorough knowledge of self, that means in every category. Genetics, social, mathematics, science, scriptural, all of it. The only way they can do it, they have to have knowledge themselves. The one to give it to you. Farrakhan doesn't have knowledge of mathematics. He doesn't have science of science. He definitely doesn't have that. He can't tell you what a molecule is. He can't tell you what gravity is. He can't explain it. He can't explain what neutrons come from. He don't understand any of that stuff. He doesn't know it. He probably doesn't even know what a neutron is. And so, for as far as gravity right now is kicking his ass, ain't it? You have to have it to know it. And we say we prove everything here. So why we don't, he pulls stuff out of his butt and say, get you all his philosophy, right? That's what it says scriptures. They take and give you the doctrines of men as though it was the wisdom of God. I'm here to give you all your knowledge back. The only way I can possibly do that is I'd have to have it myself. So you could be the judge, whether we're telling you the truth, we're giving you facts or not. But though, like I said, do not worry about those who are in resistance, because they fall in basically a couple of categories, maybe a few. Primarily demons. They have no hope. Remember the story of Nicodemus? Nicodemus told me, no, you wouldn't go into paradise. I don't care what you do. He said, I'm a righteous man. I do all the right things. Well, you had to be born again. You had to be born original, because he was a demon. See? Then you got the scriptees. See? Ain't nobody after Elijah. I got message black, how you live. That tells me everything I need to know. Okay. It didn't tell anything about COVID-19, did it? How come you miss that one? How can anyone miss that one? 1619 to 2019, 400 years of enslavement. 2020 will be a plague that will kill the firstborn, right? Which means the elderly will pass over the original people, right? Seed of Abraham. When they say it kills like flies, it's a lie, because Black Africa is virtually untouched by the plague, which they're not talking about. It should be all over the planet. It should be all on every news station that, hey, you got a whole continent over here that the plague is not bothering. It's bothering everybody else, killing everybody else. It's not bothering them people. And they're not doing virtual distancing, they're not doing social distancing, not doing mask, any of that stuff. And they have all the healthcare system, everything they have up in the West, but it's not affecting them. That should be front page news all over the place. It's not. So their gene is very similar to ours. So why in the world are we dropping like flies? Because it's a lie. It's the demons, if anyone, is dropping like flies. So in Farrakhan, the reason he should have got that one, right? He didn't get it because he's a demon himself. He don't know anything. That was easy. So now he's trying to backtrack. Oh no, we started slaving in 1555. There's no lesson saying anything like that. There's no proof for that. We came up here in 1555. We started Joseph. Joseph was brought over here enslaved and was betrayed by his brothers and captured. He wasn't enslaved. He's put in prison. And in prison, they used his brain to save the country. His wisdom to save the country. And it was his sins after him that got in enslavement. That's totally in line with the lesson. Let's say it was 64 years was in prison. And it was our children that was enslaved after 64 years. That takes us to 1619 to 2019. But now he got a story because he's a liar. See, he don't want to be Aaron. They got to keep distorting stuff because he's a liar. But if you can, like I said, okay, you're a demon. Well, we don't want you. You're scriptees. Okay, well, hold on. See, wait, okay, message. That's all you got. Well, stick with it. See, or you're a time maker. See, lost in the past, holding everybody back. Because they pretty much, that's what scriptees are anyway. There's a slight distinction between the two. See, because they hold on to, time makers, hold on to Jesus, Prophet Muhammad, whatever. See, and never move on. Prophet Muhammad moved on, left those, right, other behind. Jesus moved on, left those, but that's what happened. So we leave them behind. They're stuck in the past. The old news. He said, we make all things new. See? Okay, mathematics. So I'm going to go over a couple of things quickly to get to the main points here. Now, again, we talk about dimensions. Dimensions just mean space. So we have a situation where you have the zero dimension, means it's something that doesn't take up space, but it exists. That's a point. That's what a point is. A point is that position between two lines. If it took up space, if you put 1 inch, another inch side by it, that would be 2 inches, right? But if that point that's in between them took up space, it would be 2 inches plus something. So a point is zero dimension. A line is the first dimension. But a point exists, it just not take up space. That's something KV has a problem with. Like he had a problem with zero for 1,000 years. You go back in the Roman, you go back in his mathematics prior to 500 years ago, there was no zero in their mathematics. No zero in it. They didn't make any sense to them, right? Look at Roman numerals. There's no zero in there. But it still was powerful enough mathematics to rule everybody else that didn't have any mathematics. See, greater pressure, right, defeats lower pressure. Greater mathematics improve lower mathematics, because mathematics is pressure. Thought is pressure. Greater thought defeats weaker thought. Okay, a line, right? A line. Let me move things around here a little bit. Okay, a line is the first dimension. A line represents the first dimension. A point represents the zero dimension, it takes no space. A line, you just have a line. That's the space it takes up, a line, right? A plane, right, which people call a square or rectangle. Second dimension, see? The second, has height and length. Second dimension, it's a plane. See? As I said previously, a plane has four sides. Two sides are mirror image of the other two. So we're only concerned about half of it, because the other half is just superfluous. It's just a mirror image of the first. Same thing like here. And a line has 2 points. Only 1 point, right? We worried about, because the other point is just a mirror image, a twin of the other one. So hope you understand that. Then you got a cube, 3-dimension. 3-dimension, length, height, and width, right? It has 6 sides. But 3 sides are mirror image of the other 3, so we're only going to concern about 3 sides. See, when you get to calculus, you understand why. We're only concerned about 3, because mathematically, the other 3 is perfect. There's a mirror image of the other 3, the main 3. Okay, here we go. A geometric point. See, x is 0. That 0 means 0 dimension means it has no takes no space. X is 0. X means how long the line is, right? So if that line was 5 inches long, you put 5 there. But the 0 says it's not taking any space. That means it's a point. See, the point between 2 lines is a position. Now, a line right here, right? See, 1, that means the first dimension. X to the first, that tells you what dimension is, that 1 there. It's called exponent. It tells you what dimension is. That says it's the first dimension. See, x to the first. Now we have this thing called derivatives. Right? Now derivative is a thing in calculus. Calculus is the science of going from one dimension to another. See, multiplication, you have multiplication, division, you subtract, and addition and subtraction opposites. So when you get in calculus, you're either going up a dimension or down a dimension. Derivatives are going down a dimension when you're going down. Integrals, the opposite of derivatives, you're going up. So in this case, I use exclamation part to show that we're talking about a derivative. It's just like you put a plus sign to show addition, or a minus sign to show subtraction, or in multiplication, you got an x to show multiplication. So that just shows we're talking about a derivative. We want to take a derivative. We're going to go down and find what's the derivative of x to a line. And we find out, and the process I showed you before, is all you do is take whatever's up here, the exponent, and multiply that times the x down here, and subtract 1 from the exponent. So therefore, the exponent becomes, it was 1, becomes 0, and then the 1, you came down here, so they got 1x. So that means 1 point, because x is 0 is a point. 1 point is the derivative of a line. 1 point is the derivative of a line. Here's a square, rectangle. Has 4 sides, right? So here it is, x squared. That means that's a square, a plane, right? Second dimension, right there. See, we said 2 over x as exponent. We want to take derivative. So what you do, you take a 2, put it down here, what you did here, and you subtract 1 from the 2 right there. You got 2. That means you got 2 lines. Because x to the first is 2 lines. That's what you have here. 2 lines. Because remember we said 1/2 of it. 2 lines. Same process. That's called derivative in calculus. You go to calculus, they'll tell you about derivatives. They'll tell you that's a derivative. But they're not going to teach it to you like this. Because they don't understand the basis. If they did, they wouldn't teach it to you anyway. Okay, here's a cube. See, a cube's the third dimension. Take the derivative of that. So we'll do the same thing. Take 3, put it down here. Subtract 1 from the 3 is 2. 3. That means 3 squares, because x to 2, that's the second dimension. That means that's a square. It means you got 3 squares, right? There's the 3 squares right there. 3 planes. Remember, we only take half of it. That's the process, brothers and sisters. Okay? So here, we give an example how to use it. Very simple example, right? Where we say velocity is a line. When you move along down the road, you're going in a line. You're not going in a square, you're going in a line. Straight, you're going in a straight line, hopefully, right? You ain't drunk anything. Straight line, right? But over time. So velocity is distance, a straight line, divided by time, how long it takes, right? So he's like, that's why he say he's going 5 miles per hour. Every hour he's going 5 miles. That's what that means, right? So that's velocity, okay? But acceleration, right, means you stop. In other words, if you're going 50 miles an hour, you stop going 50 miles an hour. You're not going 50 miles an hour anymore, you stopped. Now you stop going 50 and now you're going to 60. That's it. That's why I call it your accelerator. You're accelerating. You stop going at 50. So you're at a point, from the point perspective of 50, you're at a point, you stop that. That's a point, position. So you change your position. Now you're going at 60 miles an hour. So you just accelerated. You had to apply more force. Put your foot on the accelerator for that to happen. Or you slow down, right? You're going 50 and slow down to 40. Same thing, slow down, you stop going at 50. That's acceleration. So it's the mathematical definition of acceleration. If you change your direction, you're going north, and you suddenly change and start going east, right? You stop going north. So that means you're at a point, and that point means you pivot. See, you pivot from going north, going west, or you pivot from going 50 miles an hour to 60 miles an hour. You come to a point, there's a pivot point. That's why I call it acceleration. So acceleration is a derivative because you're going down a dimension, you want to go down to a point. So we take the derivative and we get x to the first, that becomes 1x to 0. That means the derivative of velocity is acceleration. The derivative of velocity is acceleration. That's where acceleration comes from. See, and acceleration is force because it takes force. When you accelerate, you're applying force. Either you're applying the brakes, so you're down as the force, or you're applying more gas, right? That's force because you're moving it faster. And you know it because when you slow down, right? If you slow down fast enough, right, you jerk forward, right? But if you speed up, it pushes you back. So you feel the force on you. If you turn from north to west, you feel the curve, right? Because it's pushing you over to one side. So that's what acceleration is, okay? Acceleration is force. Mass just tells you how much force it is. So all mass is called a scalar. It just tells you how much force it is. Mass is not force, it just tells you how much force it is. Here's an example. Your velocity you're moving, acceleration, you stop. There you go. See, your velocity is moving, and then when you hit that wall there, now you see a force because you just accelerated. It stopped you. As of then, you see, realize the force. If you're going 60 miles an hour, this car's going 60 miles an hour, you don't feel anything. If you're going 60 miles an hour, you're not turning, you're not speeding up, slowing down, you don't feel anything. It's once you slow down or speed up or turn, that's when you feel something. So the derivative of velocity acceleration. Acceleration times mass is force, because acceleration is force. Acceleration is force. Mass just tell you how much force it is. Circumference of a circle is equal to pi times the diameter, or 2 pi times the radius, because 2 times the radius is equal to the diameter. Pi is 22 divided by 7. That's the fraction for pi. 22 divided by 7 for a circle, infinity. Same thing in AL-INJIL. AL-INJIL is 22 chapters divided by 7 seals. See, that's some mathematics in AL-INJIL I haven't really got into. That's very simple, but it's 22 chapters divided by 7 seals, circle, completeness. Okay, so here you got right here. Now, when you see that thing like a W there, see, that's called angular velocity. That's a symbol they use for angular velocity. It's not a W. It's a Greek symbol. But it's they use that to talk about angular velocity. See, that's what you need when you're talking about circles. Because when you just move in a straight line, right, that's velocity. But if you're talking a circle, you have to look at velocity a different way. Because what you're doing is looking how, see that arrow there? Velocity is the arrow is going around the circle. See, so that's what it is. So you have angular velocity and the frequency. So angular velocity times and the frequency, angular velocity equals 2 pi, right? Actually 1 pi, just pi r, because that's the radius here. The diameter would be 2 pi. So it's actually, I'm showing the circumference of a circle is 2 pi r. But the radius right here is half of that. The diameter means from one here all the way down to the bottom. That's diameter all the way through. But the radius is just from the point to the end. Okay? So that would be pi r, right? So actually, okay, that's where I made a mistake at. That should be pi r, not two pi. It should be pi r here. I'm not going to change it. Well, I don't want to change it right now. I'm going to leave it. I'll talk about it, right? Because you're talking about. No, excuse me. Here, I apologize. That's I'm thinking about something else. I'll show you next slide why. I was thinking about something else. No, that's correct, because you're talking about that 2 pi, right? It's going around the whole circle. See, that means you're talking about angular velocity, so it has to go around the whole circle, right? And the frequency, how often it does it, how fast it does it. So it doesn't make one circuit a second. It's like going around a circle, right? Okay, how many you going around? One circuit every minute, one circuit every hour, one circuit every year, right? It's like the sun. That's a circuit. Earth goes around. Earth goes in a round circuit. It goes around the sun every 365 days. That's the frequency. It goes all the way around the sun, completes a complete circuit every 365 days. That's the frequency. So I was right to begin. I had it right to begin with. Okay. See, there you go. That's the frequency. So how long it take that to do it? That's the frequency. So when you get that together, you have what angular velocity is. Because angular velocity means you're going around a circle, not a straight line. So you say, okay, how long it take me to go 1 mile? See, Here's how long it takes this to go complete around the circle. That's angular velocity. Okay, so you understand it. So here, this is the equation of a sphere. Pi times diameter. Remember, diameter means the line all the way through from one end of the circle to the other end. That's diameter. Radius halfway from the center. So the formula for a sphere is pi, which is 22/7, right, times that diameter, wherever the diameter is. Diameter could be, if it's 1 inch, 2 inches, or whatever, to the third power divided by 6. That's the equation. But now half of that, the equation for a hemisphere is pi times the diameter, right, times itself squared divided by 2. That's hemisphere. But we look over here, we find out that if you take the sphere and you take the derivative of it, you get the hemisphere. So the derivative of a sphere is the hemisphere. See, that's different rectangles. Spheres act differently, but that's the derivative. That's important because we're going to see in a minute why it's important. See, this equation, this angle, this is a more like they give you in school, but I'm not going to go into detail here. But this equation that you define what angular acceleration, angular acceleration is. Because the acceleration, we have angular acceleration and direct acceleration, like I showed you before, when that ball hit that wall, that's direct acceleration. Angular acceleration is when you're going around a circle, right? That's the difference, that's angular acceleration. And it tells you the difference between, because this right here represents this triangle, right? Called, I forget what they call that, delta. Delta times angular velocity over the change in time, right, equals this, which is actually comes out to the derivative of angular velocity, but we're not going to go into that. So we're going to point this, another concept I want you to know, understand before we move any further. Now here we have, I'm going to call it matter. That's not proper representative for matter, but you'll understand what I'm saying in the next slide. Now the universe is expanding. Now if the universe expands, that means it has to take and create space, because that's what it is. Expand is making more space. It's reproducing itself. So it's creating space. That's what expansion by definition is, right? You're bigger than you was before. That means more space than there was before. More space than there was before. Where space comes from? It has to be something there that allows this to create more space. We call that potential space. Potential means it's like you might have the potential to be a mathematician, but unless you learn mathematics, you don't have it yet. You haven't done it. You have the potential to do it, but you got to learn it, right? It's like a baby. He has the potential to walk, but he's not walking yet. See, has the potential to do it. So you have something that has the potential to become space, but it's not yet space. That's those points I was telling you about, the zero dimension. It exists, has the potential to become space, but it's not space. But it has the potential to become space. Understand that principle. So, and say it's the universe right here. It's this size. Say, for instance, now it's getting ready to expand. Now it's going to expand. What happens? See there? Now it's bigger. But what? Now you got 49. Before it was just one, now it's 49 of them. Where'd they come from? It had to come from something that had the potential to be space. That's those points in between the squares there. See? Those points, right, they weren't in space, but they was converted to space. They had the potential to be space. Very important concept. They had the potential to be space, but yet they were not space. They were zero dimension points. That concept is fundamental to understand how the universe works. So here's matter. You can't see matter. Remember, it doesn't take up any space. You can't see it. You cannot see matter. And the way they explain that is they say it's infinitesimal, which means so small, it's infinitely small. But they just can't come to the conclusion that, no, it maybe don't take any space off. It's, no, it's really small. It got some space, but it's infinitesimally. Because that's the same thing they did with zero. They couldn't conceptualize zero, so there was no zero in their mathematics. They just couldn't conceptualize it. That's a fact. Even the Romans, as powerful as they were, they had no zero in their mathematics. They just couldn't conceive of it. See? So they can't conceive that matter could be something that doesn't have any space, but yet exists. So they said we're infinitesimally small. That means it still has space, but it's just really, really, really small. See? They can't go to the next step saying, well, no, it just doesn't take any space off. See, that's why they can't apply mathematics. They can't get a mathematical math. They can't determine neutrons and protons. They don't have a mathematical equation for them. They say they can apply mathematics to it, but they can't come with a mathematical equation for it. Very important. We do. So here's matter. You can't see it. See? Okay. Now, here again. Now, matter is that there's a point right in between that cross there. Can't see it. I just put that to show you as universe expanding, this is the force that is applied to it. Because remember, acceleration is force. So therefore, the universe expanding means it puts tension upon that point. It's like if you try to take a sheet on the bed, you try to expand, right? You start stretching it, right? You see stretch marks. You take a rubber band, right? You put pressure on it, you cause it to expand. So that means universe expanding, right? So therefore, it's putting pressure on every point in the universe. It's putting tension on every tension opposite of pressure. It's putting tension on every point in the universe for it to expand. And it's turning those points into space. So this is where it is. Because the universe is expanding, but it's derivative of a velocity expanding, right? At a point will be acceleration. So the derivative of, I know some of you are mostly not going to get this. This is for those mathematicians, brothers, scientists, our brothers. You understand? That's up on this kind of stuff, but you all going to get it eventually because this is your mind. It's my job to get your mind back complete. Genetically, socially, mathematically, scientifically, scripturally, give you a complete mind back. It says a thorough knowledge of self. So I'm giving to you, so that's why I'm really pushing this mathematics, making it clearer and clearer and clearer, going more detail. See, because they don't have this. And once they don't want you to get this, they don't have this, and they're learning from it themselves. So here you are. So universe expanding. So here you are right here. And that shows you, right, the force that's on that to convert it. So we're going to say 1 unit of force, because we're talking about at the smallest level. So that's 1 unit of force, 1 unit of acceleration, right? There it is. See? It forced that in, but now there's no arrows on it because it absorbed that force of that expansion. It absorbed it. See? And notice when I did those squares, it produced a lot of smaller squares the same size it was. It produced one big square. It produced a lot of small squares. Let's go back and look at that real quick. And did you understand that? See? It produced a lot of bigger. It didn't produce one big square. It produced a whole lot of other squares that were the same size as the original square. So you'll know that. Understand that in a minute. So because the universe is spherical, it produced spheres. If the universe was squared or cube, it produced cubes. But since spherical, it produced, that's a neutron. It brought a neutron into space. That's the space. The universe spans by converting points into space, which are neutrons like that square. It produces more squares, but the universe more spheres, smaller ones. That's that. That's where a neutron is. See? And that's the equation for a neutron again. Pi is the equation of a sphere, right? But how much force did it take to create that? 1 unit of acceleration. 1 unit of acceleration it took to create that. Universe expanding. 1 unit of acceleration to create. So that means it's equal. Since that's how much it takes to create it, that's what it's equal to. A neutron is equal to 1 unit of acceleration. 1 unit of acceleration. Because that's what it took to create it. So that's what it is. That's how much force it has, how much energy it has. It's 1 unit of acceleration. That's how much energy a neutron has. See? So a neutron's energy is not matter. They get all confused. They think that's matter. Neutron's energy is all energy. Okay? But now the universe keeps expanding. So one or two things happen. If it keeps expanding, then it can produce more of these. That's how it expands. That's the only way it can expand, by creating more space. And space creates neutrons. But now when it expands, right, that expansion, now neutrons are already created, but now it's still expanding. So now that expansion is still affecting neutrons, so either it create another neutron, or it can make that neutron start spinning. See? But it would take 1 unit of acceleration to cause the spin. So that means now it's spinning, it'll be 2 units of acceleration. That's how much energy it would have. But once it starts spinning, it's not a neutron anymore. See? It's a proton, because now it's spinning. A spinning neutron is a proton, because now it's spinning. And everything that spins, right, has torque. Neutrons have no torque. We're going to show it in a minute. Torque is what they call electron. Neutrons don't have them. But spinning proton, spinning neutron is a proton. See, that's right here. PID to those 6, right? That's what I said. That's a neutron. That's great for neutron. But spinning makes it, right? That's it. A spinning neutron is a proton. The spin generates torque called electron. That's why protons have electrons. I'm giving you all the mathematics of it. Okay. So here we have it. A spinning neutron, that's what it is, angular, that's what that thing looks like a W there, right? That means it's angular velocity, right? So that means it's spinning. Angular velocity is spinning. A spinning neutron is a proton, which equals, since it's spinning twice, it means 2 times, because we said before that a neutron, right, is equal to. Let me go back and show it. See what I said? I said a neutron is also equal to acceleration. 1 unit acceleration, which is also equal to velocity, derivative of velocity, of angular velocity, derivative of angular velocity, right? So it's equal to this, that's equal to this. So you look at it either way when you look at it. So then that would mean that since it takes angular velocity, a derivative of angular velocity to create a neutron, and the spin, they're both equal, so it's equal to 2. So that means a proton is equal, see, a neutron is equal to just 1 unit acceleration, right? That's what a neutron is, 1 unit acceleration. I just showed that. But it takes another unit acceleration to cause the spin. So it takes 1 unit acceleration to bring a neutron into existence. 1 unit of acceleration to bring a neutron into existence from a point. But it takes 1 unit of acceleration also, right, to take and cause it to spin. So that means a proton then is 2a. It's a neutron, right, that's spinning. So it takes 1 unit acceleration to bring it to existence and 1 unit acceleration to spin. So a spinning neutron is a proton. So that's the equation for a neutron. Proton is twice right? Velocity, derivative of twice the velocity of angular velocity, or just twice, 2 times, right? Or twice the angular velocity. Angular acceleration. Hope you understand. I know it's kind of complicated. So this is angular velocity, right? This means, and the frequency, that means angular velocity is 2 pi times the frequency, right? Which is angular velocity, where F is the frequency, where frequency is how often it completes a rotation. Frequency how often it completes a rotation. We talked about that. A spinning neutron is a proton. The spin generates torque called electron. I know it's kind of confusing for some of you. You need to study. It's up to you. So here again, now spinning, okay, if you take the derivative, remember I said the derivative of a sphere is a hemisphere. This is a hemisphere here. So you take derivatives, you get a hemisphere. Hemisphere is an electron. So what electron is. It's a hemisphere. It's the derivative of a proton. See? Actually, this is not correct here because, well, I'm saying spinning. I do say spinning here. I'm going to show it in a minute because it should be a spinning equation. I just say spinning, right? I say spinning. So there you go. See, instead of spinning, I put angular velocity here. So we take derivative of that. That's derivative of proton, because here's a neutron, pi d to the third over 6 neutron, multiplied times angular velocity, right? That makes it a proton. Neutron, spinning neutron, this represents spinning, this thing like a W here. That makes it a proton. Derivative of that gives you electron. So electron spins. So it has torque. That's why it can move. Anyway, that's another story. So here we have angular velocity, right? Which is 2 pi times frequency, angular velocity, where F is frequency, where frequency is often it completes a rotation. A derivative of a proton is an electron. So here we have it again. Well, this shouldn't be here, but anyway. Derivative of a proton is electron. It's an electron here. See, it's 2 electrons here because they fit together. You have a thing called shells. Around a proton or atom, you have shells. You have one shell, then you have another shell out of it, then you have another shell, and we'll talk about that in a second. But here it is. Here is the neutron. Here's your neutron, spinning neutron. That's that W thing there, looks like, right? That means it's spinning. That's angular velocity, right? Derivative of that gives you angular velocity, right, of electron, which is hemisphere. Okay, now if you look in here, look closely, you see a lot of spheres inside here surrounding that proton. That proton is spinning, right? Spinning. That means a neutron that spins a proton. So I have protons written, they're spinning. See, it's spinning. Neutrons don't spin. So you have, see all these spheres around it? You got 1, 2, I'm only showing 1, 2, 3. 3 spheres around. Those are called shells. Those are called shells. And each shell has so many electrons. Now the first shell has 2. The next shell has 8. Next shell has 18. Why is that? Because the surface area of electron, that's the equation for the surface area of electron. So the first electron, right, is just equal to pi. We'll talk about that in a second. See, the first shell is just equal to pi. Half of that, right, first shell here is equal to pi. But half of that would be pi over 2. See, because this here equals the whole area. Pi r squared equals the whole area, the surface area of each one of these spheres. But half of that would be half of a hemisphere. The hemisphere. So hemisphere represents electron. So the first one, right, would be half of what the surface area is. That means that'd be pi over 2. Okay, so that means you put 2 electrons in the first one because that's the surface area of that sphere, right? But half of its electrons, that means you put 2 electrons in that level. But on the next level, right? So let's see if we show on the next page here. Okay, but the next shell level, if you do the multiplication, you're going to say the area, the surface area of that sphere is going to be 4r instead of 4 pi. The first one was just pi. The second will be 4 pi. If you do the mathematics, find what the surface area will be. The next one, it'll be 4 pi. But that means if an electron is only pi over 2, that means you put 8 electrons in that level. But 8 electrons in that level will fit because each electron is the same size. So you go to the next one, and you put 18 electrons. That's why you see those diagrams. You see like 2 in the first one, and like 8 on the next one, and 18 on the next one. That's what it is. But that's what happened here. And they're not points. See, they give you the diagram, they give you, and when you go to school, everything is point. Because they don't know what electron looks like. Their microscopes cannot see electron. The reason why they can't see electron, because electrons do not. Okay. Be careful with this one. Electrons do emit photons, but what you see is photon. You can't see electrons because electrons, right? Your eye is only sensitive to photons. So that's where electrons come. They come from. That's where photons come. They come from electrons. But you only see the photon. I'm not going to photons here. The mathematics behind it is very simple, but that'll be the next one I go into because I'm trying one thing at a time. So you can see the photon, but you can't see the electron that created it. Because that's what creates photons, electrons. When they move from one shell to another, their energy either absorb energy. When they move to a higher level, they absorb energy. When they move back to a lower, they emit energy, and that energy is called a photon. Okay. So anyway, that's shells. And I told you how that equation works. 1 squared, then you got 2 squared, then you got 3 squared, and you multiply times 2. So 2 times 1 squared is 2. 2 times 2 squared, which 2 squared is 4, is 8. 2 times 3 squared, which is 3 squared, 3 times 3 is 9, times 2 is 18. That's what you have here. It's an easy equation. Okay, this is where I'm going to get to the meat of it. See what happened there? Those two things came together. That's called fusion. That means you're forcing, see, those are protons. You're forcing 2 protons together. That's fusion. But it takes force to keep them together because they won't stay together. Because they're like magnets, you know. You got 2 magnets, 2 positive sides. They won't come together. You can push them, but as soon as you let them go, they're gonna fly back apart. They won't come together. They won't stay. That's fusion. It's trying to push them together. That's happening in the center of stars because the gravity is so great, it's able to force them together. That's why it takes super stars. Our sun can only produce the most complex atom our sun can produce is helium, which is only 2 protons and 2 neutrons. But you need a super star to do something like iron or a uranium. See, super. So why do we have uranium on this planet? Why do we have all? Because our planet is the core of the universe. That's at the Quran said in the beginning. There was the earth and there was the heavens. And heavens were they were one. So the heavens were the size of the earth, the atmosphere of the earth. And then we expand. So all you see out there used to be the atmosphere of the earth. That means the earth was extremely hot and extremely condensed. It was a superstar, the greatest star ever. It was so much pressure there, right, that it was able to make super atoms like uranium and things like that. That's what happened in here. That's the proof of it. Because you can't just put those things together. And KV just can't make them. You just can't make them. It takes superstars to do it. That means if you have all the elements that's possible in the Earth, that means Earth was the center of a superstar, the greatest star ever. And then we expanded. Somebody say exploded. That was the so-called Big Bang. Anyway, see these came together like that? Okay. Well, I'm not, you can read this, right? I'm not going to go ahead and play it all.
Fusion.
Okay. Now, let's back up here. Now, this thing is spinning. Now, remember, it came as a result of spinning, stretching the universe. So it's part of the universe. It's an integral part of the universe. So they think particles are something that's separate from the universe somehow, and they're independent. That's wrong. They're part. This the fundamental part of the universe is like one material. That's why I call it universe. It's one thing. See, but it's spinning. That means it's forcing. It's like a current. All they have a fan that's turning and it's making the air circulate around it. Well, this spinning causes space around it, right? Cause it because it's remember it's when it's stretched, right? See, I show it like this here, but it's really a continuous thing, right? But it's stretched, right? So therefore, the space around is stretched. We're going to show that in a minute when we get to gravity. But it's spinning. That means it's causing a current around it. It's building a current around it. And this current gets weaker and weaker as it goes further. That's why it says, remember I said a proton is 2 times acceleration. A neutron is just A. That's not A there. That's acceleration. It's 1A. But proton, since spin is 2. It's 2 because it takes twice as much energy to make a proton as it takes to make a neutron. It takes twice as much energy. It takes 1 unit of energy to make a neutron. It takes 2 units of energy, right, to make a proton, because now a proton is just a neutron spinning. That's what that 2A. Acceleration is energy. It's also force. Okay? So the further you get away, that's R. R means the further you get away from it, right? So it gets weaker. That's what it means. So you divide this by whatever R is, the distance. So as the distance gets further, this current gets weaker and weaker and weaker. That current is called charge. See? Because you build that current. That's what keeps photons coming together. Because you got a current around them, and that current keep pushing them away. That's what that is right there. Hope you understand that. See, this other red around, that's like the current. That's right. That's called charge. Okay. So here we have an example again, right? So this, see here, this got a current, this got a current around it, and this force in between it, right? See, but as it gets closer and closer and closer, right? That's the force. That's the force when they get close together. 2A, still the same thing because that's 2A that makes them. But that 2A gets as it gets closer and closer and closer, right? When they touch, then you get the full because they're touching now. So it's not 2A right now. But as it gets closer and closer, it becomes 2A when they're touching each other. So I should actually show that. It becomes this when they're actually touching each other because the full force of the current is at that point. See? So here, there it is. That's 1/10 unit, 1/10 unit. That's the force that's pulling them back apart. That's they're pushing. See? Because each one is 2A. So that current, now you're pushing them together, that current at that point is 2A, 1 tension unit, which is one acceleration, one. I'm just going to say A. It shouldn't be saying A, but 1 acceleration unit, 1 acceleration unit when they're touching. When they're touching. That's how much force is pulling them back apart. That's very, I mean, really, the force is pulling them about. When I say 1 tension unit, I'm talking about 1A, one acceleration unit. 1 tension unit is 1 acceleration unit. See? Over here, same thing. Together, that's 2 of them. That's why it says 2A here. Together, right? So that's how much it's trying to pull them back apart. They're pushing because that current is pushing back apart, like magnets pushing back against each other. See? What's going on here? Okay, I'm back up. Okay, So here it is. Now, see, in other words, if nothing holding, they come back like they were before. See, they're like that. If nothing holding them, whoa, 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 back up, back up. Went too far. You see it like this, right? But if you're pushing this and nothing holding them, they'll go spring back. See, look at those yellow things like they're like rubber bands, right? Tight. So you push together and nothing holding, they're gonna spring back just like they were before. See, push it back again. You got this force that's pulling them back together, pushing them back away from each other again, right? But this time, this happens because the force that was pulling them, you can look at either way. They push apart or pull them apart. If you look at it pulling apart, the force that's pulling apart was two acceleration units. Two acceleration units was pushing them back, pulling them back apart. But one acceleration unit is a neutron. One acceleration unit is a neutron. A proton is two acceleration units because one has a neutron and then one causes a spin, which converts to a proton, right? But one acceleration unit is just a neutron, not spinning. So you got two acceleration units trying to pull this thing apart. So if instead, if they're held close together long enough for that force to pull a neutron into existence from a point, right? Because that point's ubiquitous, means everywhere. That means it's resolved. There's nothing pulling together apart anymore because it pulled those into existence instead. That's how a neutron holds a proton together, hold protons together. Because they absorbed the force that was pulling them apart. Because that's what a neutron is. It was two accelerating units pulling apart, but you got two neutrons, because you need two neutrons to hold together. This is a helium atom. You need two, you can't just one. So now it absorbs it so they stay together stable. There's nothing pulling apart anymore. That's where it works, brothers and sisters. See? Now we're going to talk about radiation stuff later on, but bottom line, this is stable. It's a little, there's a little instability, very little. They call it a weak force. The reason that is because it didn't pull it from the center. It's pulling it from the side. It pulled from the center to be totally stable. But pull from the side means there's a little instability there because it's a little off center. And when you have a big complex atom like uranium that builds, so it's built unstable, so it's easier to break them apart because you got the instability factor increases. We're not going to talk about that here, but I just gave you a little hint there. So that's what's happening. So now that's how neutrons work. They pull into existence, so now it's stable. It's virtually stable. And that's a helium atom. Helium atom is two protons and two neutrons. Okay. Now we're talking about that. We're going to talk about, well, that's changed that. I messed up some here. Okay, we're talking about fusion again. I show you how they hold together. It's next. Here's fusion. You push two protons together, fusion, push them together. They're not going to stay together, right? Because you got to not stay together because they push that current I was talking about this before they spinning. It's going to push them apart. See, but in gravity and stars, heavy gravity pushes them together. The heavy gravity of stars is enough to push them together because it takes a lot of force to push them together. See, we say young unit. Well, that means small, but from my point of view, remember, we atoms too. That's a lot. Okay. So they fuse together. And then if two neutrons come in, I have them come in like that, but they shouldn't come in like I showed you earlier. It produces there, then it holds them together. I'm just showing fusion, you have to apply two neutrons to it. But they have to come together like I showed you earlier. It can't come flying in, right? It doesn't happen that way, right? Those are different type of neutrons anyway. But you get the point. Now, fission is just the opposite. See, fission, so you have pressure. Fusion is pressure. Fusion is pressure pushing together. Fission is tension, is the opposite of pressure. Like addition is opposite of subtraction. Everything has opposites. So fusion, right, pushing together. Fission is boom, boom. That's the bombs that they dropped on Hiroshima, fission bombs. Because they took this, that's what called splitting the atom. That's called splitting the atom. In other words, they cause the atom to break apart. But a fusion bomb is just the opposite. See, that's called thermonuclear bomb. I told you they take a fission bomb that's powerful enough, right? They have hydrogen in the center, hydrogen gas, right? Which is just protons. But this hydrogen, this fission bomb, powerful to force those protons together. See, so then you have fusion, but there's no neutrons there to keep them stable. So once the fission bomb explodes, and it's spent, there's nothing to hold those protons together. That's fused now, so they explode. And that's a more powerful bomb. That's thermonuclear bomb. So this is the way fission works. So here you got the atom, helium atom, for instance, right? See, those neutrons are not spinning. They don't spin. When they spin, they become protons. So now it's stable. It's high helium atom. And you pull away the neutrons, and then nothing to hold them together. Bam. That's a fission bomb. That's how fission works. See? And they move it apart at speed of light. In that little spot, you create a temperature high as the sun, that little spot. But it moves out at the rate of 1 over r squared. We talked about that earlier. So at one point, maybe a billion degrees at that one point. But inch away, it may be just slightly lower than a billion degrees. A foot away, it may be down to a mile away, 100 yards away, maybe down to 1,000,000 degrees. A mile away, maybe down to 1,000 degrees. You see what I'm saying? It's because it's getting cooler, but it's still hot. 1,000 degrees. If 1,000 degrees hit you, you're gonna burn to its crisp. That's how time bombs work. Because those atoms are moving so fast, because that's what heat is. Temperature is how fast atoms are moving. That's what temperature is. So if you say 1,000 degrees, that means they're moving around real fast. 1,000,000 degrees, they're moving around really, really fast. 1,000,000,000 degrees means they're moving extremely fast. That's what heat is. They move really fast. See? And when they hit you, right, they move because yours move really fast. That means that's why you burn up. Because your atoms move so fast, they can't stay stable, they come apart. That's what fire is. So that's how time bombs work. Move really fast. So they split those atoms right there. They move around so fast. See, in that little spot. But as they move out, right, they start cooling. They're moving not so fast anymore. But at a mile away, it still may move 100,000 miles an hour, 1,000 degrees, right? That's where you have that blast spreading out, shock wave. That's where it works, brothers and sisters. This is your wisdom, your knowledge. This is how you made heaven and earth. Right? So the people that's telling you all this stuff, they need to. How they gonna teach you thorough knowledge of self, the universe, they're talking about gods and everything, they don't understand any of this stuff. KV doesn't even understand it. Okay, gravity, then we're gonna wrap this up, brothers and sisters. Here's gravity. Now gravity, they don't understand gravity. When they talk about gravity, they talk about the mathematics that applies to it, but they don't understand what it is. Einstein came with his theory, right? They don't know, they still call it theory. They don't know it's a fact. They still call it theory, right? So we're going to talk about what gravity is, because gravity affects everything. See, but one thing you understand, protons and neutrons, because the way they were created, right? They look like spheres, but the space around them curves. Space around them curves. I'm going to show it in a second. And it gets weaker and weaker as it curves further and further away. The only thing that they display space because they're not out of space, they're a part of space. That's what they don't get in quantum theory and all that kind of stuff. They're a part of space. That means they display space. when you turn that point into you displace a space. Okay? They displace space. That's very important. See? Okay, let's move on. Okay, here you go. See all these circles? That means the area around these are all say these are all neutrons here. They're around it is curved because they're curved. So it's like if you throw a rock into a pond, right? You see all the circles that come out? Well, that's what it is. When a neutron, the space around them is like that. It's curved because it's curved in the way because it was formed by tension pulling, you know. So the space around is curved. So I'm showing you when you put a whole bunch of them together, it's going to increase the curvature of the space around them, right? So what you see here is that see up top here, this top and up top here, say it's a proton neutron by itself, but it displaces space. That means the space, if this space that's in is curved, that means the space closest to where the center is, right, is going to be more tension than the space on the other side of it. See? See, I said, you see it's right here, got 1 over r squared green and 1 over r squared red, right? I think you can see it. Well, maybe you can't. Hold on. Maybe let me make it so small there. Okay. Well, no, maybe a little smaller. Okay, I think you can see it now. Maybe I should do it this way. No, it still won't work either. Oh, I see. Okay, let me leave it like that. Okay, on top here, I got a red arrow. It's the same equation as the other one. Only thing is that it depends on r. Now, r is the distance between the center and to that point. So the distance between the center and that point in this first r is less than the second one. That means the tension here, because as it spreads out, the tension becomes weaker and weaker and weaker. Because here at the center, the tension is greater because it takes up less space. As more, you have to spread that tension over a greater space. See? So in other words, here, say a circle right here was a mile in the middle. And a circle out top was 10 miles. Well, say if you had a can of paint, right? And you just, the paint gonna be thinner on the one on the 10 miles because you got one can of paint, you got spread over a longer distance. So it's gonna be less. But at the center it'd be more because you don't have spread over only a mile. Here we have spread over 10 miles. That's what 1 over r squared means. Okay? So what it means is that the gravity, closer you get to this, it's going to be stronger because you have less space you have to occupy. And the gravity on the other side is going to be, so you got displacement here. So on one, since this is space, then it's going to be a distance between here and here. So the one side, the gravity is going to be, the tension will be greater, which is going to be towards the center. Other side will be less. So that difference means it's going to be a differential. So if you're pushing, and I'm pushing at 10 pounds per square inch, and you pushing at 5 pounds per square inch, right? Then what does that mean? Put this back over. I'm pulling at 10 pounds per square inch. You're pulling at 5 pounds per square inch, right? That means I'm going to pull you closer to me because I'm pulling at a greater force than you are. If I'm pulling at 10 pounds per square inch and you're pulling at 5 pounds square inch, then I'll pull you closer to me. That's how gravity works. Because it's curved. See, space is curved. And it only works with neutrons and electrons. That's why if you drop an elephant and a pin, you drop an elephant and a rock, right? Or a Coke bottle. If you drop them from a mile up, they can hit the ground at the same time. You say, well, how is that? I mean, the elephant's where? Because it doesn't look at the size of the elephant. It looks at the electrons, it looks at the protons and neutrons of the elephant. Let's just look at that. That's what we're looking at. Because that's the only thing that displays space. right? So it's like you say, for instance, you had a bag of potatoes, right? And you take all say a whole bunch of potatoes, you tie them together with string. So each string was like 1 inch, right? And you tie it to another potato. So you make all your potatoes, and they separated by 1 inch string, right? But they're all tied together, right? Then you take that and drop that with that all you got 100 potatoes, they're all tied together, right? See, they're loose, they're tied together like on a net or something, right? And you got one and you drop at the same time, they'll hit the ground at the same time. Because why not, right? That's the way it works. They hit the ground at the same time. Even though you got 100 pounds of potatoes over here and 1 pound here. But they're not looking at how many you got. There's like individual protons, individual neutrons. That's why that works that way. And so there you go. That's how gravity works. Now these clouds, they can't tell what gravity is. They're planning on what gravity is. And Farrakhan, gravity's kicking his ass nowadays. That's how gravity works, bro. It's just, I'm giving you back. It's my job to give you all your knowledge and wisdom back. This is knowledge and wisdom. You need to know to control the universe. This is the universe I'm teaching you about. I'm teaching about your universe that you are the God of, that you made. See, you didn't create the universe, you made it. The universe has always been here, but we change formlessness into form. We give form to formlessness. All this energy out there was just energy, but we gave it form. It's just like, 10, it's just a number. But if you say make it 1 plus 9 or 2 plus 8 or 5 plus 5 or 3 plus 7, you give it form. So universe was just a number. Universe 1. It was just number 1. That's all it was. And you took and made it, gave it form. Stars, even Kavi says you don't understand why the universe has form. They tell you if you go study physics, they don't understand why the universe has form. They think it should just be a big cloud of gas, cloud of energy. They don't understand why it has form, because we gave it form. Okay, Bones, I think that's pretty much it here. Oh, well, it's going to give you, there's a few more things here. Watch that. See what happens? It's moving closer and closer because displacement, displacing space. And one side is more, the pull on one side is greater than the pull on the other side. You can pull on both sides, but one side is greater, pull on the other side, so it's moving you closer to the center because you got more neutrons there, so you have more curved space. The more the curves, the greater the curvature of space, the greater that pull is. Okay, now we're going to pretty much wrap this up. We're talking about triangle here. Like I said, most of Cavy's science or mathematics based on a triangle. See, the fact that this square plus this square equals that square. So whatever is here, you multiply times itself, that gives you square. And here multiplies itself, gives you square. And you take whatever line, and they always come to call it Pythagorean theorem, as though they created, but that's most of their math is based on triangle. Very powerful. Vectors, same concept. Triangle here, they shift these up. They shift this up and shift this over, and as they get this, right? And this plus this equals this. The reason why this is straight, because this and this is equal. If this was greater than this here, then the angle would change. This angle, this will start moving this way. If this line become greater. This became longer than this, then this angle, this will start moving this way. If this become greater, then the angle will start moving that way. Because it's centered because the angle here is equal. But this plus this equals this. A plus B equals C. It's the same thing comes from here because this comes from here. That's vector, very powerful. Trigonometry, triangle again. The fact that the angle, we're talking about angles, the angle of every triangle is 180 degrees. You add all the angles to always get 180 degrees. Like this, 60 degrees, you add them all to get 180. Add all these together, 90-degree angle is always a right triangle, right? It's always perpendicular, right? That's 180 again. That's trigonometry, is based on that fact. That's how they kind of find a star or anything. If you know the distance between like LA or New York or any place on the planet, the difference between this and this, right? And you have the person that's here, and the person's here, draw a straight line to whatever they're trying to find out the distance, a star or whatever, right? And then they tell the person what the angle of their line is. The angle of their line is, once they find the angle of this line and know the distance of this is, what this distance is, then they can figure out what that is, which is distance here without even going there. That's how you can tell how far the stars are. Even though the stars they see, probably some don't even exist now. Because when they look out there, they're looking at millions and billions of miles, billions of years into the future, into the past rather, because it took that long for light to get here. Light travels at 186,000 miles per second. If you're billions of miles away, it may take hundreds or millions of years to get here. That means when you look out there, you're seeing what was going on way back then. And that's why I look at these powerful telescopes, look further and further back in time, because now they're starting to see little evidence of us moving around out there at super speeds, much faster than the speed of light. We can go faster than 24 billion miles per second. It's faster than the speed of thought. So that's why I talked about that, but you don't understand where he was coming from. See? So the garden is wide as the heavens and the earth. It would not be a garden if we could not get out there in a reasonable period of time. We can get to the nearest star as fast as you can go from Newark to before you can go Newark to Philly. See, we don't play games. We ain't effing around. We're the gods. They took your mind away, but I'm giving it back to you. You will not return to get thorough knowledge of yourself and have somebody give it to you. I'm giving it to you every respect. Mathematics, genetics, I talked to you about genetics, about how we got nappy hair, all that kind of stuff, because we had nappy hair. Only a few of us had it. It's a dominant gene. Only a few of us had it. And that was the gods, because they had the most dominant genes. The science, that's why I said, let us make man our likeness and image, because most of us didn't have it. That's why it calls angels. It was gods, but lower gods. See? But now, the whole idea of us coming here to make sacrifice to raise up to the level of other gods that makes our image and our likeness. See? So when you got the nappy hair and the real dark skin, you're looking like the original God looked. That's why a lot of Muhammad said when you look at original man, looking at God, because now you look, that's where he looked. Where he looked and looked. Farad does not look like the original God looked, but that was on purpose. But he's still a God. Don't get it twisted. Don't make that mistake. That'd be a big mistake, brothers and sisters. He ain't here to hurt you, but he is the God, and we better respect that. See, because he's the one going to save our ass. I have the tickets, brothers and sisters. I do not have the vehicles. See, now you got the conductor and you got the ticket sales. You got to get a ticket to get on the vehicle, right? But even a ticket guy, if he wants to get out of town, he still got to get on that vehicle. And he's not getting on there unless the conductor accepts this ticket. That would say, when Michael came, he only took those who was in the Lamb's Book of Life, he had tickets. Where you gonna get that? Where you gonna get those tickets from? We'll get it from the scalpers, Farrakhan, Sasna. They won't be recognized, believe me. We're not stupid. This is where that 100, see, a circle is 360 degrees. But if you take a circle and you break it up into 4 parts, there you got ready. Put these 4 parts together, a circle. But each one, if you break that, means each one would be 9 degrees, right? You break 4 parts. 4 times 9 is 108, 360, right? 90, 180, 180, 180 is 360. So that means here you have what? 90 here, 90 here, 90 here, 90 here. Okay? But to get a triangle, you got to split in half. That means you're only going to have 90 here, you're only going to have 60 here, 45 here, and 45 here. That's where you get 180 from. Half of the 160, half of the 360. Okay? Is that it? That's it, brothers and sisters. Hope it's been helpful. Hope it's been informative. We're going home, brothers and sisters. See, will the prey be taken from the mighty? With their wealth. But they're trying to go off that standard. See, the gold standard and the silver standard. See, you don't understand what they be talking about in the background. See, that's what Nixon did. He went to gold and the silver standard. So your money used to be worth how much gold. You used to say on your dollar bill how much gold you could go to the bank and get for that dollar. They don't do that no more. They went to gold and silver standard. They said, I'm not going to all the standard. But right now, they're on the gold and silver standard with us because they need us for our creativity. That's the reason why they need us here. That's why you're valuable to them. That's the gold and silver they talk about in Exodus. Said we go out with great wealth, gold and silver. And it's us. The silver is Levites, and we're the gold. We're the creativity. Because without creativity, they can't do anything. They need creativity. You're a technician, but you need blueprints. Without blueprints, you can't do anything. And we give them the blueprints. They stole all our creativity. That's what whole Joseph. Remember, they used his creativity to save the country. That's the whole story of Joseph. The country was born, and he saved them with his creativity because he was able to solve puzzles no one else could solve. You got to understand these stories. See? But then they enslaved their children, his descendants. That's the story. They need our creativity. But they're trying to get off that gold standard. They're trying to stop relying on that. That's when they want to go to cyborgs, mechanical world. Because once they create the mechanical, they won't need our creativity anymore because they got their computers and everything. They're cyborgs now. They need it for the biological and everything. They don't need it anymore because they use that creativity to get where they're going. And they want to finish off, and they want to get once, because they know both of us can't exist. One of us would have to go. We cannot coexist together. See, they know they cannot exist in this biological world because they don't understand it. They need us to stay in it. So they can bring the mechanical world. See, cyborgs, they still have biological brain, they can't get around that. They have a mechanical body. Brothers and sisters, you don't understand. But they need once they achieve that and they're very close to it, then they go up to gold and still stay on this anymore. See? But now they have to make a choice. You see, God's coming after them. They know 16, 19, 28. That was an easy call, bro. It's an easy call. Trial, kind of CSIs, it gets right there. Either follow scripture, don't follow scripture. It's right there. Exodus clear. If I ask you can't go wrong. You can't get lost. God came, Elijah had a spokesman that was a hypocrite and a liar, right? Deceived the people 40-some years. And then Joshua, who was a follower of Elijah, right? Then he's the one breaks the seals, right? Puts down Aaron and takes us home. Assalamu alaikum, brothers and sisters.